Good afternoon, everyone.
Hello.
Hello. Good to see you again. Um, yeah, it's the last lecture. My last lecture. Time has gone by very fast this block. Good to see you all again. We're going to wrap it up. Um, the final lecture on a continued topic for this block, namely the regression analysis. So, dare I say I saved the best for last? Well, I at least like the moderation analysis very much. It's a pretty it's a decent analysis, and so we'll share this and save this one to for the very last of the analysis with which I've shown you, and well, looking back, we've provided you with I hope, a very decent understanding of how to conduct research. I hope we've been able to elevate your knowledge of statistics and give you the tool set to at least go on and be able to perform research on your own, at least during our studies at the psychology department. I'll come back to this in the end, but our tool set that we provided you have gone from, in the first block, a little bit of repetition of what we had last year with the t-test. We gradually introduced R and SPSS. And now at the end of the course, you should be able to perform, well, all kinds of research design where you have groups to compare. You're even able to do that in a fashion where you do repeated measures and combine that with independent groups, with control groups. And in this final block, we've added quite a variety of regression analysis which you can use, where our moderation analysis is the final icing on the cake, so to speak. Of course, there are many more statistical analysis and techniques that you can use, but we won't cover that in this course. But in the rest of your study, we'll deepen that knowledge for your specific field that you choose. So, we'll cover the moderation analysis. We'll see how it relates to the things that we've been doing so far. And of course, we'll try again to visualize what we're actually talking about. But what is this moderation analysis? Because again, like essentially yesterday, we had a mediation analysis, and it's an analysis which has its own name, and that would suggest that it's something special. But as you hopefully will see, that it is just another variant of just a linear regression model. So in statistics and regression analysis, the moderation analysis occurs when the relationship between two variables depends on a third variable. And this third variable is referred to as the moderator variable, or simply the moderator. And the effect of the moderating variable is characterized statistically as an interaction. So if I state this, then what kind of analysis does it remind you of? So if I say the effect...
ANCOVA?
You're saying an ANCOVA. Is there anyone who agrees with ANCOVA? Or is there anyone who does not agree?
Isn't it just a t-test?
No, it's more than just a t-test, because we're having multiple predictive variables where we call one the moderator, and they are both continuous variables, just like the regression analysis that we've used. But the term interaction should trigger something, and the thing that is triggered by one of the students was the ANCOVA. But if you look at the ANCOVA, you're essentially doing an ANOVA, but you add a covariate. So you have some predictor variable that is a group variable, and you add some continuous confounding variable to correct. And we did use the interaction in the ANCOVA, but do you remember why we used the interaction in the ANCOVA? And when? When did we use the interaction in the ANCOVA?
To check for the assumption. I don't know what assumption.
Indeed, it was to check for the assumption. Which assumption was it? Again, anyone else?
That the dependent variable is evenly distributed across the levels of the independent variable.
The levels of the dependent variable is, you say, evenly distributed, and I wouldn't call it evenly distributed. It does need to be the same
Equal.
effect on exactly equal on the different categories. So one of the assumptions for the ANCOVA was that the regression slopes, the relation between your covariates and your outcome variable, that relation was the same in one category as the same as in the other category. So that was an assumption. So we actually did use the interaction term, but only to check if this was essentially not the case. Because if the slopes weren't the same, then we violated the assumption. So which other test did we use where we did look at the interaction?
Could you repeat the question, please?
So which test did we use where we did look at the interaction term? One of our previous tests that we've discussed during this course.
A chi-square?
No, not the chi-square.
The factorial design.
Yeah, the factorial. Someone put it in the chat, right? And indeed, the factorial design. And what made the interaction term relevant in the factorial design is that we essentially had two independent variables where we wanted to know for both if there was a main effect, and we wanted to know if there was an interaction between these two independent variables in explaining the outcome. So we've covered examples where we said, does the effect of the experiment is the effect of the experiment different for men and for women? So you could have a control group and an experimental group, and then you could have another independent variable, gender, which would indicate males or females, and then we could see if there was an interaction between these two. So that is a place where we looked at the interaction before. And so if you only look at this description of what the moderation analysis is, what do you think it represents then in that sense?
How do you mean? What does it represent?
Yeah, what does the interaction do in this case? If normally an interaction that we've used was within the ANOVA analysis, the factorial ANOVA. What's different between this, the moderation analysis, and, for example, the factorial ANOVA? What's the difference here?
I guess in the factorial ANOVA was about the interaction of two independent variables. It wasn't it? Yeah.
Yeah.
And and what kind of effect that has on the outcome variable, and moderation is between the independent or the predictor and the outcome, right? So it moderates the effect, the interaction between those two, I guess.
Yeah,
Because there are no several predictors, right? Just one.
Yes. So we're stuck here again at the same point that we've discussed yesterday, where we call one of the variables something special. We call one of the variables a moderator, but in essence, it's just another variable. So we're giving it a special name, but in essence, we have two variables that try to explain the outcome. And in terms of the factorial design, we had two variables, independent variables with categories, that tried to predict the outcome. So in that sense, it is a different name, but that's not really the difference, right? Because they both try to do that. So again, what do you think is the difference between the factorial ANOVA and the moderation analysis?
Is it that with a moderation analysis, we're only interested in the interaction effect?
Oh, that's a good point. So with the moderation, you're only interested in the interaction effect. Well, then that is true, but you could also state that for the factorial design for the factorial ANOVA, right? You could state that if there is an interaction in the factorial design, is it still relevant to look at the main effects? Well, that's something to ponder about. So this is a good one, but there's still an even bigger difference for the both.
Maybe in the moderation analysis, we are interested in comparing two models. The one model being the predictor, how the predictor affects the outcome, and one in which we include a second variable, the moderator, and how that changes the relationship between the predictor and the moderator.
Okay. Well, within the moderation analysis, we still only use one model. So where we had the regression analysis, right, yesterday and last week. Last week. We could do one model and see if we add by adding another predictor variable, could see if something additional occurred, or the model would be better. Within the moderation analysis, as was stated earlier, we're mainly interested in the interaction term. So that is a correct observation. And in terms of interaction, well, if you're looking at it from a regression model perspective, this is the interaction term. So last week we've looked at the repeated measures and the multiple regression, where we had multiple predictor variables, but within the moderation, and that's the naming thing, we call one of those predictor variables, we label it moderator, and it's statistically this is just another variable. So the thing that makes it a moderation analysis is the fact that we add this interaction term, where we quite literally multiply one variable with the other and give it a separate beta coefficient. So it's just one model. let me point you a little bit in the right direction. What kind of variables are these? What kind of variable is this? Is this a continuous or a categorical variable?
Continuous.
Continuous. And the moderator, is this a continuous or a categorical variable?
Continuous.
Yeah. So what is the difference between a moderation analysis and the factorial ANOVA?
Variable type.
Sorry? The variable
variable
type.
type.
Yeah. Exactly. So the factorial ANOVA looks at categorical variables, at the main effects, of course, and the interaction effects. And within regression analysis, within this moderation analysis, we do the same, but with continuous variables. So it's just an application of a regression model where the interaction term is included with continuous variables. And that means that you can have the let me phrase it differently. Within the multiple regression that we've seen last week, we didn't apply this interaction term, right? Do you remember? We just had one predictor, the other predictor, and the error term, but the interaction was not in there. Do you remember?
Yes.
And we had this 3D plot, and I showed you this 3D scatter plot yesterday also, where you saw that you could get for both the variables, both the predictor variables in that case, you could get a regression plane. That was the green plane. And the thing that we saw was that we could have the slopes for each of these variables was the same, independent of the level of the other variable. So if with low variables, if with low values on one variable, you could have a relation that was like this. Also with higher levels of that variable, the relation stayed the same for one variable, and if you turned it around the other side, it was the same still. And by adding this interaction term, it allows your regression model to show a different relation, a different linear relation on the different levels of, in this case, and that's why we call it a moderation analysis, on the different levels of the moderator. So with low levels of the moderator, there might be a positive linear relation, whereas with with very high levels of the moderator, there might be a negative linear relation. So by adding such an interaction term, you allow your model to have different linear relations at different levels of the moderator. And well, the way the way you show such a moderation effect, or how do you say that? Visualize it in such a way that you know that's a moderation. It's like this, but what it essentially means is doing formally a regression analysis with the interaction term added. We'll go into an example, and then I'm gonna ask you to try to come up with some hypothesis, for example, for this research. So this is the example taken from Field in this chapter, and in this chapter, Field looks at the relationship of playing violent video games and aggression. But he also had measured and he calls that the callous, unemotional traits, and that means that it's a trait, first off, and it's a bit of a weird wording that he used, callous, unemotional, but it means something in the line of that you're quite an evil person. Hardvochtig in Dutch. So if you are highly unemotional and a bit evil by nature, he uses that as a moderator. So there are three things at play. One, the amount of aggressive behavior. Two, the hours that kids play violent video games, and three, the unemotional traits. So can you think of any hypothesis that you could have for such for this example?
Maybe that the numbers played per week have a positive relationship with aggressive behavior if the unemotional traits are, or if people just have many, how do you say that? If they display a lot of unemotionality, if they don't have an unemotional trait, or if they score high on unemotionality or something. So that when the predictor goes up, the outcome goes up when the moderator is high.
Yeah, so you're saying when you have a high level of unemotional traits, then there's a strong positive relation between the hours spent gaming and your aggressive behavior. Yeah. Compared to what?
To compare to if you do not have that high unemotional trait.
And but what then would you expect the relation to be when you have low unemotional a low unemotional state trait? Do you think it will be flat?
No.
And what would it mean if it was flat? Anyone else can pitch in if you want to. What would it mean if there was a flat?
There's no relation.
Exactly. So you could say, so one of the hypotheses that you could pose, as you stated, is that if you have a low level of unemotional traits, there is no relation in playing video games and your aggressive behavior. But when you have high levels of unemotional traits, then there's a strong positive relation, right?
Yeah.
Very good. Is there anyone else that can come up with a different hypothesis for the same relation?
Maybe people high in callous emotional trait are low in aggressiveness when they don't play video games.
Okay, yeah, but do keep in mind that the video games measures was measured in hours of gaming. So you could say that what you're saying is that if you have a low level of if you don't play that much and you're high at the unemotional traits, you have
low levels of aggressiveness.
Low level of aggression. But what happens then if you play a lot?
If you play a lot, then the level of aggressiveness go up as well.
Yeah, so you're also stating there's a positive relation between. No, that's no problem. But the thing where I'm trying to get at, what do you think? What are the differences, kinds of hypotheses that you could state where you your co-student
could say the difference, right? So the other way around, that if you are unemotional, that you are less aggressive when you're playing.
So with other so that's what you're saying. If you have low unemotional traits, then you could also say it makes you less aggressive, right?
Yeah.
That's what you're saying. Yeah. So what you're seeing here is, and you have to think about the unemotional, and I'm going towards you and away from you to indicate that the moderator is a continuous variable, right? So getting higher levels of the moderation means you have a positive relation between hours of gaming and aggression, whereas you say as you have lower values of unemotional traits, you could have no relation between hours of gaming and aggression. But you could also go further and state that if you have very low unemotional trait values, you could even have a negative relation between hours of gaming and aggression. Right?
Right.
Very good. So that means that in terms of hypothesis, you could have a hypothesis that just says, well, if you're low on unemotional traits, it's just flat, there's no relation. And if there's high levels, there's a positive relation, but you could also have a different hypothesis stating that it will be negative. Why would it be negative? Anyone?
Maybe
Why? Yeah.
because if you have high, so if you're an aggressive person or you have those traits,
Yes.
that the video games, playing more video games kind of relieves your aggression, which is why you show less aggression, so that the video games kind of lowers your levels of aggression instead of heightening them.
Oh, exactly. So you are posing even a different hypothesis. You're stating that if you have high levels of unemotional traits, then playing many hours of aggressive video games will actually lower your amount of aggressive behavior. And then you could contrast that in terms of your moderation values, that if you have low levels of an emotional trait, would you say that it flattens out, or would you say that it turns into a positive relation?
I think it would turn into a positive relation. That's what I would say as a hypothesis.
So you're saying people that are very have low levels of unemotional traits, if they play more video games, they show more aggressive behaviors.
Yes, because it triggers something in them that wasn't there before.
Very
maybe.
good. So you see that we now have 3, and we could think of some more different hypotheses of what this relation, what this moderator would do in describing the relationship between hours hours spent in the video games and the aggressive behavior. It can be from positive to negative, or it can be from positive to flat, and there are different types in which you can hypothesize what this relation would be. And what we're also seeing is that they're not categories, right? So you're not saying with a low value I see this and with a high value I see that. No, because you model the entire interaction into your continuous variables of the of both the moderator and the predictor and the outcome, because they're all continuous variable in our regression analysis. It means that you for each level it will, if you go from a positive from a negative for a positive relation, negative relation to a positive relation, then the plane essentially shifts, going towards you and going backwards. So this is very good. So this is the way you need to think about moderation, not just we have a variable that influences. No, how do you think it will influence, and how do you think that based on your theory this relation would change? Because I could also state a different hypothesis, for example, where you would say that people that are highly unemotional, the playing video games trigger the aggressive behaviors, whereas people with low unemotional traits, then for those people, playing aggressive video games actually lessens the amount of aggressive behavior because it's a stress relief. So you could view the same interaction in very different terms. And of course you have to test all these these hypotheses if it holds for you.
Would it be better to test the hypothesis that is not the null hypothesis of there is no, the effect is flat, like 0, because then you're not testing again?
Yeah, so of course your null hypothesis always stays the same, right? So this is talking about your alternative hypothesis of the thing you think as a researcher will be the relation based on theory, and you try to refute the null in this one. So that's correct.
Yeah, I have a quick question.
Go ahead.
So you have to test the moderators on different levels then, right? Because a lower level could have a different effect than a moderate and a higher level of the moderator, right?
Exactly.
So maybe it's in the next slide. Well, how do you do this? So
Yeah,
how would
we'll go into this, yes.
Oh, okay.
No problem. Very good. So you're eager to see the next, and we'll go into that. So for this, I'm gonna simulate some data, and simulating data for the moderation, you actually need to have values that are centered around null, so you are able to have positive and negative numbers. So I create some predictor variable, and I'm calling it the predictor and the moderator and the outcome variable to make it clear, more clear during in the slides what we're talking about. But we are actually talking about predicting aggression based on the hours spent gaming with the unemotional traits as a moderator. So this is a random normal variable, and we determine the moderator as being the predictor with some noise. We add some error, and in the final step we define our regression model. And if you look, so the predictor and the moderator, they are both continuous variables in this sense. So actually creating my outcome vector, the numbers, means that I'm applying a regression model, exactly the regression model that I've shown here. I have the beta coefficient, the intercept, B0. I have some weight for the first predictor. I have some weight for the moderator, and I have some weight for the predictor times the moderator, and I add some error. And if you look at what I'm doing here, I have the intercept, I have some weight for the predictor, I have a weight for the moderator, and I have some weight for the predictor times the moderator plus some error. So this is exactly how a regression with an interaction works. It just multiplies both the two variables. So what we've put in here is a beta coefficient, a slope for the predictor of 0.5. I'm stating that for the moderator I have a negative relation. That's a bit weird, but let's try that. And I have a relation of 0.4 with the predictor times the moderator. Yeah, it's very evil construction workers outside here at my home, and I don't think I can get rid of them, so sorry for that. So I want to do this example with not centered on 0, but have some values for the mean of the predictor that's higher, around 15. So if my predictor variable has a mean of 0, then I can just add 15, and then, well, I have some different variables. This is not really important in understanding, but it's just to show you, at least show you that creating regression variables is just, well, essentially quite easy to do. Yeah, the question in the chat is, where did the 0.5 and the minus 0.4 and 0.4 come from? I just made it up. I'm simulating data. I'm putting it in there, and the reason why this is interesting to do, I'll just call it interesting, is because you can see if your regression analysis actually is able to recover these parameters that I actually put in here. Because if it's not, then your regression model is not really working. So we can also check if that works out for us. So this is our data. We have the so if you run if you want to do the moderation analysis and gather data, then you actually this is what you get in your data set, right? You have some predictor variable. In this case, it's the hours spent gaming. We have some moderating variables. In this case, the unemotional traits, and we have the aggressive behavior as outcome variable. So as a data set, you would just have in SPSS 3 columns with continuous variables. So let's try to look at this in SPSS. So we're going to SPSS, and I have these 3 columns in here. So what I first want to do is run these analysis within SPSS by using the process package. And just like yesterday, I want to ask you to run me through this. So what do I need to do to get to the moderation analysis?
Analyze, regression.
Analyze, indeed, and then?
Process, regression process.
Regression, indeed, and I've got process installed already. And this comes up in my other screen.
I guess the model number is different now, right? Because 4 was mediation, so it's probably not a number.
Yeah, so we have the aggression, and we have the unemotional traits, and we have the hours of gaming. So indeed, the model number is different. Do you know which number it needs to be? Anyone?
I think it's 1.
Yeah,
1.
indeed,
Right.
it's 1. Very good.
I have a question.
Go ahead.
Is 2 not the same model as 1, only with the moderator at Z?
I have no idea.
Oh, okay. Because I think I
And that's
accidentally did 2 once.
okay.
And
Yeah.
with the moderator and Z. But I'll use 1 then.
Yeah,
1 and
just you. No, I have no idea because Hayes doesn't state what he's doing with Model 2, and I touched upon this yesterday already. That well, it's very nice that Hayes made this addition and extension to SPSS, but it's really inconvenient to not know what this 2 stands for. And he's written a book, and you can buy the book, of course, and then he will explain what he's doing in Model 2. This is a smart guy.
Smart man.
Yeah, indeed. So, well, we'll be sticking to using Model 1. Field explains that you need to use Model 1, so we'll stay there for now.
Okay.
So, which variable needs to go where? Ah, they stopped.
Aggression Y variable.
Yes, the aggression is the thing that we're interested in, so that's the output variable.
Hours game probably X.
Exactly, because we want to see what the relation is of our predictor, the hours spent gaming, and the amount of aggression, and then we want the moderator to be added. So what do we do with this?
That's probably intermediator, but that doesn't make sense because it says mediator.
Yeah. So where does it need to go?
Probably X var or
Anyone
covariate?
else?
I don't know.
Moderator.
Yeah, so we
variable.
have mediator, we have covariate, it's not a covariate, we have moderator. Yeah. We'll put it in W. So you see the naming, and there's also the possibility to add another moderator variable, but we only have 1, so we'll do this one. And we have some options, and again this shows up on my other screen, so I'll drag it over. Um, anyone?
Show total effect model, I guess.
Sorry, could you repeat that?
The third one, show total effect model.
Yeah, but the show total effect model applies to model 4, 6.
Yeah, that's why I was confused.
Yeah,
We
so we
wouldn't
don't
have to have an option for
no,
that?
no. So
Oh,
because
okay.
we're not looking at effect sizes in
Yeah, okay.
essence, we're actually just looking at the 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 interaction term. So we don't need this. So what is useful is to get to generate some code for the for the interaction. So we could create a graph showing the interaction. So that is useful.
Johnson-Neyman output
The Johnson-Neyman outputs could be handy.
and the conditioning values to be centered. So the second
Centered.
option.
Yeah. So with the so this is the mean centering, and you've seen that with simulating data that I went from data that was centered around null to adding some value. But what you often see within the moderation analysis is that you center your data, and the reason why we do this, and I think we've talked about this before at some point, is that you want to interpret the beta the slopes, the beta coefficients at a certain value of the moderator. And what the regression analysis mostly do, especially when you control for your second predictor, is tell you what the relation is between what your beta coefficient is at the level 0 of the other variable. And we've discussed this before, that is sometimes a little bit, let's say, illogical, because if one of your variables would be heart rate, for example, then it would give you the beta coefficient on some other variable with a heart rate of 0. And, well, that is a bit strange, because then you would be dead. So by centering, mean centering, it centers on the mean, and the value of 0 is assigned to the mean. So if your regression analysis gives you a result, a beta coefficient, when correcting for the other variable, it will again be for where the other variable is 0, but the meaning of that, because we've mean centered, it actually states that we get the beta coefficient of the mean value of your other variable. So in this case, it would give you the beta coefficient of the relation between hours spent gaming and the graph shift behavior at the mean level of the moderator, at the mean level of unemotional traits. And that is why we mean center. Does that make sense?
Yeah, but do you only do this when you have a moderator that cannot have a value of 0, or do you always do this?
Well, you don't have to. Essentially, in interpreting the interaction, you don't specifically need to mean center. But if you don't, and you're going to look at the main effects of the beta coefficients, then you really need to realize what the meaning of the beta coefficients is if you do not mean center. Okay. So it's a bit of a choice in that sense.
Okay.
Sharon, just a quick question.
Go
so
ahead.
When we interpret the beta coefficient for a variable in the model, that beta coefficient is at the value where the other beta coefficients are or no, not the other beta coefficients, but the other variables are at their mean. So each
Yeah.
beta coefficient is
that is true for the result that your regression analysis give you. So if we let's see, if we go back to the slides.
we don't see the slides.
Oh, sorry. This one. This beta coefficient is the slope for the predictor while everything else is put on 0. So at the moderator level of 0. And if you look at the beta coefficient for the moderator, it will be the beta coefficient when the predictor is at 0.
Okay.
Yeah? Very good. Good question.
Question?
Yeah, go ahead.
That the 0 is in that case the mean then, right?
Yeah, exactly. So if you mean center, then the value of the moderating being 0 means it's the mean. Yeah, exactly.
Okay, thank you.
Yeah, very good. Okay, so if I go back to SPSS, then we have a few more options. As I recall, you could have the standardized. No, this is for the mediation. We could do the pairwise contrast of the indirect effect. No, this is not relevant. Show covariance is also not really relevant.
What does the Johnson name and output do?
Yeah, I'll get back to that.
Okay.
Test for M interactions. I think we need this one, and the residuals correlations is not really relevant. Yeah. Okay, so I stated that you. Now let's first run this analysis. Let's do that first, and then we'll look at the results and try to see what's going on here.
But do you not have to select under conditioning values the one standard deviation mean?
Yeah, so we have a few options here, right? You can conditioning values you can have at the 16th, 50th, and 48th percentiles, or you could do that based on the standard deviations. And let's do that. Let's do the standard deviations, one above, one below. And this is one above and one below of the mean of the moderator, exactly. So we'll run this analysis and we'll have a look at the output for this. And this will probably take some time to run again in SPSS. Let's go to the output. Oh, where is it? Did I do something wrong? No, here it is. And I think this will take some time again, because it's very hard to run a regression analysis.
The variables are too long.
Oh yeah, yeah. So you've seen this also, I think, within the weekly assignment, right? Or the WA. So this is an interesting part on the program of Hayes, because we have a special button here, and it's called long variable names. So if we look at this one, then we can also check that our variable names are longer. And well, this I find this mind-boggling that you can write a program where your outputs can be different if you have long variable names. Okay.
I have a question.
Yeah, go ahead.
Under options, you did interactions of M, but isn't M for the mediators?
We'll see what the output will get us. I think you're right. Yeah. So it's mainly about the regression model. And
why would you click the option of incorrect output for the long variable names and not just shorten the names of the variables?
Because it's more work at this point to shorten my variables, and I'm willing to risk it at this point. I've done it a few times already.
Right. Okay. Thank you.
Okay. Um, what I think is happening is that he made this output, and it's all very neat. You see, it's all in line, and I think that if you use long variable names, he will not be able to put it all in the same line and line it nicely like this. And I think that is what he did. Maybe. Well, okay. So, what are we seeing here? Can you describe what we are seeing?
Well, we have the regression model, so we have the beta coefficients for the variables and for the interaction.
Exactly. So we see that this is just a regression model, right? Only with the interaction term added, and the interaction is here. He created one variable which is called interaction, and the interaction is essentially the multiplication of hours spent gaming and unemotional traits. So what we get is, of course, well, is it a good predictive model? So we get our standard regression analysis output, the R squared, the R squared, the F value, and the test if this is actually a significant model. And yes, it is. And then we get our beta coefficients for our regression model. So we have the constant, which is the intercept, B0. We have the slope for hours spent gaming. We have the slope for unemotional traits. And these beta coefficients, these ones are the beta coefficients when the other variable, unemotional traits, the variable is at 0, right? And the other way around. So
0, I mean centered.
Centered, mean centered, and which means that if you put it at 0, it's the mean. Indeed, that's. So what we're seeing is the beta coefficients for your entire model here, and what we're also seeing is that we, if you test the beta coefficients with a one sample t-test, which is done here, then we can see if that variable, if the beta coefficient is significant or not. And what we're looking at is the interaction term, because if there is an interaction term actually based in the data, then it's relevant to look at the moderation, because if there's no interaction term, well, then there's no interaction going on, so there is no moderating effect. So in our case, we have a t-value for the interaction of 13.9, and we find that this one is significant. So there is actually something going on. So what we're seeing now, so I'm scrolling down here. So looking at the regression model, it states, well, it is a relevant regression model. We have a high levels of explained variance. It's significant. Our interaction is significant. But now what? Because we've hypothesized about what the interaction could be, right? We thought about the interaction, the relation between hours spent gaming and aggressive behaviors on the different levels of the moderator. We've talked about what kind of hypothesis we could have, and if we look at our data, if we look only at the fact that we have a significant interaction, it doesn't tell us what actually is going on. So we need a way to look at what the relationship is on the different levels of the moderator. And that is where, when we ran the analysis, and we looked at the options, we could state that here, our moderation and conditioning, that we, on the conditioning values, we could indicate that we would want to know what the relationship on the different levels of the moderators are. And here we chose to show the one standard deviation lower than the mean itself, and one standard deviation higher. And that is what SPSS or HAZE, the process package, is providing you with in this first conditional effect of the predictor at the value of the moderator. So what is it saying? It's saying that at the level minus, so that's lower than the mean, of 4.12, the effect is minus 8225. And it's saying at the unemotional trait level of 0, the effect is 0.7, and at the unemotional trait level of 0.12, it's 2.2. So what is this saying? Could you explain to me?
I think it says that at minus 4.12, which is minus one standard deviation level,
Yes.
the aggressiveness is at minus 0.882 when the hours of gaming are kept constant. So I think.
Okay, so this is a good point you're making, because you're now referring again to the hours of gaming kept constant, but that was the case when we looked at the beta coefficient in the regression model. Sorry, let's view this. That was the case when we looked at the beta coefficient in the regression model. But what we're doing now is we're looking at a specific value of the unemotional trait. So we're not averaging out or keeping the other variable constant. No, we're looking at a specific point of the moderator and what the relation is between hours spent gaming and aggression for that specific value of the moderator. So when we are looking at when we are deep diving in and finding out where the relation exactly is, we're not keeping it constant anymore. No, we're now saying, well, exactly at this value, what is the relation here? So going back to your point, and someone else can chip in. Yes, you're at one standard deviation below what again?
Mean?
The mean of what?
The moderator.
Moderator.
Exactly. So one standard deviation below the moderator. The relation.
Sorry, we can't see the screen.
Oh, sorry. Yeah. So one standard deviation below the moderator value, the relation between hours spent gaming and aggression is minus 0.82.
So that would be the slope of the...
Exactly, that is exactly the slope of the... So with low values of aggressive, of unemotional traits, we're seeing a negative relation between hours spent gaming and the amount of aggressive behavior. So a theory could hold where you state, well, playing video games, if you're low on unemotional traits, actually works as a stress relief. What is it also saying? It's saying that at this 0, what is this again?
Can you scroll down a bit? I can't see the output.
Yeah, it's
Thank
this
you.
one.
Yeah.
So at what level is this of the moderator?
The mean.
Exactly. So at the mean of the moderator, so people that are average on unemotional traits, there is a
Positive effect.
positive effect.
Small.
It's small. So the slope won't be like this, but it will be a bit less steep, it's 0.7, so we have a small positive relationship between hours spent gaming and aggressive behaviors.
I have a question. Can we actually speak of an effect in this case? Because even though it says so, like in the table, are we actually seeing an experimental design?
No, we're not. No. Because you haven't manipulated the situation. You're just looking at the
Right.
at the
It's
variables that
correlational.
it's only correlational still, and
All
that's the same issue with which I had with the mediator analysis yesterday. That it suggests that you have some pathway to the results, or that one thing leads to the other, but it doesn't. So in some cases you could design experiments, right, where you do manipulate one situation and then at a later point measure the other variable, where you really do have some time in between to see if this can be a cause of something else, and then you can flip it around to see if, well, okay.
Yeah, I just found it curious that it said
exactly.
effect in the
Yeah.
table.
So the effect here means what the effect is of the slope, and we've seen that yesterday. We also called it with the mediation a direct effect and an indirect effect, and it's all relating technically here just to the beta coefficients and the slope of the relation.
Yeah. All right. Yeah. Thank you.
So in the final step here, we see that for high levels of unemotional traits, there is a
High positive effect.
very high positive relation between the hours spent gaming and aggressive behaviors. Okay, we need to have a break. We'll start at 1:15. It's time to get something to drink. I think I had enough coffee for today already, so I'll get some water. And after the break, we'll continue this topic and we'll go into the visualization, because the visualization helps to understand what parts we are actually looking at. So, something to drink?
Yes.
Yes.
Very good. See you at 1:15. Okay, we are continuing. So we now have at least 2 points, or let's say 3, at which we can find out what the relationship is between hours of gaming and aggression. And I told you that it always helps a bit if we can visualize this relation. And within the process options, we ticked that we would like to have SPSS create some code to visualize. And well, instead of just giving us a plot, it's actually literally creates code to help us visualize this effect. And we can find this code here at the bottom.
So we can't see this.
Oh, sorry, yeah. Even at the last lecture, I still don't learn. Okay, we can copy this code, copy and run this in the SPSS syntax. So if I create a new file, and that would be a syntax file. Let's see if this works. Yeah, it works, but it shows up at a different screen. And I paste this syntax, select everything and run it. Then it will create a plot for us. That is this one, which is still not really informative as we look at it. But if we double click the plot, we are shown the chart editor. We click one of the dots, and now we have the options to, let's see, add fit line at subgroups. I think we used this at one point. And this makes it a bit more insightful. So what we're seeing here is that we have for the low level, for the low level of unemotional traits, this is the blue one, the relation between hours of gaming going up from left to right, and it's mean centered, so this is the mean hours of gaming going up and going down. We have so we see that there's a negative relation for people that are low on unemotional traits. And for people that are at the mean level of unemotional traits, there's a slight, that's the green one. There's a slight positive relation between hours spent gaming and aggressive behavior. And finally, if we have a high level of unemotional traits, there's quite a large slope. The beta coefficients are quite high, and we see that here in the, well, reddish purplish line showing the higher the amount of hours spent gaming, the higher your aggressive behavior is. So this is essentially a visualization of the slopes that we found for those 4 levels of unemotional traits. Does that make sense?
Can I ask something?
Go ahead.
Do they always mirror each other? So there's minus 4.12 and then 4.12 on the other side for the positive relation.
Yeah, so we
or
chose.
is it just a coincidence?
No, it's not a coincidence. We chose to choose to show the relation at one standard deviation above the mean and one standard deviation below the mean. So this standard deviation is minus 4.2. So if you choose for both sides to have one standard deviation, these values will be the same.
Oh, right. Okay.
Yeah.
Thank you.
So this is quite it's not a very subtle and nuanced view on the relation of the different levels that you could have, right? So within the options in SPSS, we also were provided some more insight, and one of them was this one: the conditional effects of the predictor at the values of the moderator. And what we essentially see here is a whole bunch of different levels of the moderator. So instead of just showing 1, 2, 3, we now have a complete list of all different values of the moderator and with their associated effects on that level of the moderator. And this is the result of jumping up. This is the result of the Johnson-Neyman test that we selected, because what the Johnson-Neyman test essentially does is determine at which points we have a significant positive relation or we have a significant negative relation. Because if you use the interaction between these two variables, that means that you're going to your regression plane is going, in our case, from negative to positive. So there is always, if you have such a regression plane, there's always an inflection point where it goes from one side to the other, or you have a point where it's just flat and it goes up, or it's flat and it goes down. That could be the case also, but there's always a point where you have a flat plane, and at that point the relation between the two, the predictor and the outcome, is non-significant. So you're always going to have a point where your slope at one point is significant, and beyond, of course, it will also be significant. But if it changes from a positive to a negative, you will have a point where it's not significant anymore, and then it goes to negative, and then we will find a point where it is significant again. And the Neyman, the Johnson-Neyman values that are shown here are those points. So minus 2.79 is one of those points where we find the value to be significant again. So that's on the one hand, and the other is at minus 1.06. And well, this gives us an indication on which levels of the moderator we find these effects. But in the second table, we see a lot of levels of the moderator. So we see the level of the moderator. We also see the beta coefficient on that level, the effect. And this effect, this beta coefficient, is tested with the one sample t-test. And we get a p-value from this. So it tests if this is significant. So when we see the beta coefficient go down, getting smaller, it comes closer to 0, and our t-test actually tests if our beta coefficient differs from 0. So at one point, if it goes from negative to positive, then we will have the 0 point in here somewhere. So if we're testing this in a t-test, then at some point it will not be significant again. So we have not here high values of the high t values, and they are getting smaller as our beta coefficients also get smaller. And we see the associated probability of such a t value, if the null is true, getting higher and higher until this point here, where the p-value is 0.05, and the t-value associated with that is minus 1.9, and the associated slope is also negative, it's 0.3. And we know that this is at the level of the moderator of minus 2.7909. And that is exactly what is indicated above here. That is the point where the inflection starts. And then if we still go down, we see that our p-value even goes up, because we go from one side, it flattens out, and then we go to the other side, and here it's significant again. And if we look at the value of the beta coefficient, this is now positive, and we have a beta coefficient of 0.3077. So we flip from one side to being non-significant to the other side, and the level of the moderator for that positive relation at which it is significant is minus 9.505. So with the Neyman, the Johnson-Neyman addition, you can find out at what points you see the relation between the hour spent gaming and aggressive behavior at the different levels of the moderator, at which point it's not significant anymore, and when it is significant again, flipping to the other side. So you have a bit of a nuanced view on what the relation is. So in the beginning, starting at this lecture, when I introduced this research, I said, well, what kind of hypothesis do you have on this? And then it was stated that maybe for high unemotional people, playing video games is actually a stress relief. Or maybe if you're not unemotional, if your unemotional traits are low, then there's no relation. Based on what we see here, we can actually answer if the data that we find are in line with our hypothesis. So what hypothesis holds here based on these results? Anyone?
Can you put the screen from the output up one more time?
So I'll zoom in a bit. So what hypothesis holds of the interaction?
That when the unemotionality is low, the effect of the predictor on the outcome variable is higher? Wait, no.
You were starting out very good.
Good, yeah, no.
So
when the unemotionality is low, then the effect of what was the predictor of hours game on aggression is negative, so it has a negative effect on.
Exactly.
Or there's a negative relation between the two. That is
compared to?
If the emotionality is high, that there's a positive relation between the hours gamed and aggression.
Exactly. So our moderator has the effect here in terms of our interaction, that it's a stress relief for people who are low on unemotional traits. Playing video games actually makes them less aggressive. Whereas if you are high on the unemotional trait, it increases your aggressiveness. So that hypothesis holds. And the hypothesis doesn't hold where we said maybe people with low amounts of unemotional traits, there is no relationship, because there is. We see that there's a negative relationship. So we had a few of those kinds of hypotheses, right? And based on our data and based on what we find, this is the one that holds. Does that make sense?
Yes. I have a question though.
Go ahead.
Because you have a small, if you go back to the output, you have a small area where I guess people have moderate unemotionality, but where it's non-significant.
Yeah, so that's here.
Would you have to take that into account with your conclusion as well, as so to say that the moderator has no effect when?
No, I don't think that's really relevant, because the way that the interaction term in the regression model works is that it always goes, well, if there is an interaction and it flips, so there will always be a point where there's no significant interaction. So
okay,
is that really relevant? I doubt it. Well, you could state, of course, that people with exactly this amount of unemotional traits, there's no relation between the two. But then again, of course, your model has model error, because all models do. So in that sense, I would just phrase this in terms of your hypothesis that you're trying to test to see what holds in this case. Okay?
Yeah, thank you.
Good, very good.
Sharon, just a quick question regarding the display.
Yeah.
The column effect, that would be the beta coefficient of the moderator multiplied by the predictor, right? In the regression model.
No.
No, that would be okay.
No, it is just the beta coefficient. Oh, sorry. Yeah, it's not the multiplied. It's the beta coefficient.
The interaction.
It's the beta no, the beta coefficient of the interaction is this one. Sorry, it's this one here. And what we're seeing here is the beta coefficient. Oh, sorry. Here. So these are the beta coefficients of the relation between hours spent gaming and aggression at this specific level of the moderator. I'll go into this because it's a good question, and you really have to try to get a grasp on what such a beta coefficient and the slope means on specific levels on the of the mediator. So I'm going to go back to my slides. And I will be going here then. Yeah. Try to go to full screen again. Let's see. So we've looked at the data. So I have the predictor, the moderator, and the outcome. And of course I can create a scatter plot of these. And I can see what the relation is of the moderator with the predictor. And I can also see what the relation is of the outcome with the predictor and of the outcome with the moderator. And what we see that there's a clear linear relation between the moderator and the predictor, right? We see this. But if you look at the outcome related to the moderator, then, well, this is not a linear relation. And if you look at the outcome compared with the predictor, this is also not a linear relation. Why is this, do you think?
Because we said that on low levels it has the one effect, and on high levels it has the other effect. If it would be linear, then it would have the same effect continuously over all levels.
That's absolutely true. Very good. But we are doing a linear regression, right? So what gives?
We have more than 2 variables. We have 3 variables in the model. So
no, we only have the predictor and the moderator in the model, right?
And the interaction. So
the interaction, very good. So that's the point. That's the key. The fact that we put in the interaction means that you can fit your linear model at different values of the moderator. The fact that your regression plane can do this is because we put in the interaction term. So we're fitting our data to this, well, seemingly odd-looking relation. So we're going to look at this again, but from a few perspectives. So we have again the predictor, so that's the hours spent gaming. We have the outcome, which is the amount of aggression. And again, this was always a bit hard in my slides to properly move. And we have the moderator, which is an emotional trait.
I have a question.
These go ahead.
Is this the three-dimensional image of what we just saw in 2D?
So exactly. We were here in 2D. So if you look, for example, at this relation, this is no, let's look at this one. This is the outcome and the predictor. So we have these 2 points here and this one there. So let's see if we can find that. These 2 points and this one there. So this one is this view, the relation of the predictor with the outcome. You see that?
Yeah.
And for the other ones, so if we're looking at the moderator with the predictor, this is quite linear. The moderator with the predictor, so that's the moderator with the we need to go up. It's the moderator with the predictor. So it's, yeah. moderator, predictor. Yeah, it looks quite linear. These 2 points at the top. Moderator, predictor, these 2 points at the top. You see this?
Yes.
Very good. So this is the same as I've shown you with the multiple regression, right? So if you don't take a moderator or a second variable into account, you will have the flat view, even though such a moderator could have an effect. If you don't take it into account, you only see this. But now we do. We take the moderator into account. And what we want to do is with the, for example, we looked at the 1 standard deviation above and below, right? So what does that mean in terms of this 3-dimensional scatter plot? If we want to know what the relationship is of the predictor, hours spent gaming, and aggression, outcome variable, on the mean of the moderator and 1 standard deviation above and 1 standard deviation below, what do we need to see in this graph? Or at what points are we interested in?
So we need to look at different levels of the moderator.
Exactly. So which levels?
The mean and 1 plus minus 1 standard deviation above.
Exactly. So if we're looking at our moderator, then our mean might be here somewhere, and then we would have 1 standard deviation above going up and 1 standard deviation going down. So we want to know at this point, that point, and that point what the relationship is through this dotted cloud of data of the predictor with the outcome. So let's see if we can get this. So if we want to create the 1 standard deviation planes, I'm selecting the mean of the moderator and adding the standard deviation, and this will result in this. And I really went all out. I now can make animations with this. But what we're seeing here is exactly those 3 points. We have the point of the mean, which is here. So the mean of the moderator is here. And 1 standard deviation below. So this is a lower value of the moderator. And 1 standard deviation above of the moderator. Does that make sense?
Yes.
Very good. So now at these planes, at these blue planes, yeah, so the question that I see in the chat, how come is that it's now not 0? Because I haven't mean centered my data. I just used the uncentered data. Also to show you that you don't have to mean center. The mean centering you do because the regression model on how to interpret the beta coefficients of your regression model. But if you're looking at the entire data, well, you can plot it like this. It's not mandatory to mean center in that sense. So you have these 3 points, and one thing that you essentially want to know is what is the relation of hours spent gaming here and the amount of aggressive behavior at the first plane, just the 1 standard deviation below, the middle, mean, and 1 standard deviation above, plane. So how would you go about to do this? Can you eyeball it? Look at the data points and think, well, it should be around what? You have any idea?
I'm a bit confused. What are we doing exactly?
We want to know what the relation is between hours spent gaming, the predictor,
Mhm.
and the amount of aggressive behavior, the outcome variable, at one standard deviation below the mean and one standard deviation above the mediator, the amount of unemotional traits.
Also, whether it's positive or
Exactly.
negative. Okay.
Exactly. So if you eyeball this, can you see what the relation is at these levels?
It's negative, isn't it?
First,
Uh,
you can see that it's negative, right?
Negative in the first plane.
Negative in the first plane. But can you see it? If you look at the data points, can you see what this relation is?
No.
No,
Well, I
it's
would
very
say
hard, right?
you'd
How
have
do you
to
know which of the red dots belong to which plane? Because some are just in between, right?
Yes, exactly. So the fact that you have a plane does not mean that there are actually dots there, because you could have data that's not within exactly on the plane, and we could look and see if we find any dots that are, well, really on the plane. For example, this one, it's very close, but it's very hard to determine what the slope, what the line would be there. But what we were doing is we were fitting a regression model. We were fitting a regression model to determine what the beta coefficient was for the first predictor, the second predictor, and for the interaction term. This is unstandardized, by the way, not mean-centered. And if I have a regression model, if I actually have the values that belong to this regression model, my beta coefficients for the intercept, for the predictor, for the moderator, and for the interaction between the predictor and the moderator, which is falling off my screen at this point. Can I make it smaller? No. I can apply this regression model. So what I will do now is for each and every possible value of the predictor and each and every value of the moderator, I will apply the regression, this specific regression model which I've created, to come up with an expected outcome. So if I do this, then I will, what will I get here? What do you think? What will be the result of applying, if I apply this regression model and I plot all the possible values of the predictor and I plot all the possible values of my moderator in the same graph that I've shown here? What will I get?
You maybe get like a line, like a kind of like an average line of the three planes, maybe.
It's not an average line. It's,
I don't know. It's just like the three lines and then add it up together, and then what comes out of that. So, like,
I understand. Yes. Anyone else?
Like a curved plane or something?
Like a curved plane.
Because
Yes.
it can't be this anymore. It has to be.
Because we
yeah,
added the
like this.
interaction term for each and every value of the predictor and the moderator, I will get an expected value of our outcome. So if I apply this and I go back to the slides,
like, does it look like the 2D ones? I kind of, am I onto something?
look, here we have it. It's again a plane, but it fits the plane to the data. So the fact that you have an interaction term here means that you allow your regression model to be able to show this interaction, to show this flipping. So if you look at this, for each and every level of the predictor, for example, if I put in 20 on the predictor and I put in, let's say, what is this? 0 for the mediator, my expected value is this point, this point on the green plane. And if I put in 18 and let's say 1 for the mediator, 18 for the predictor, and 1 for the mediator, my expected value is, of course, again the green plane. So the entire green plane that I have is essentially applying this regression model that we've just created and applying every possible value for the predictor and the mediator, and that will show us the expected value for each and every value that we have. And this is our regression plane. And the difference with the difference of this with the compared to what we did with the multiple regression is that in the multiple regression it was a flat plane, and it was flat because we didn't specify an interaction term. We didn't allow the model to flip. Only because we do the multiplication in the regression model, it can flip. And that is what we're seeing here. So if I now ask, so this is the regression plane that we have. So if I now ask you, what is the relation or the slope at 1 standard deviation below the average of the mediator, below the average of unemotional traits, at the mean of unemotional traits, and 1 standard deviation above the unemotional traits, you can see the slope quite clearly because it's the intersection of your regression plane at this specific and the blue plane, which was the plane that indicated at which level of the moderator I wanted to see what the slope was, right? Do you see this?
Yes.
Okay, so now I'm going to do something. I can flip it up a little bit, and you can see the depth here, right? So this is the first one, this is the second one, and this is the third one. And if you look at the intersection with the regression plane for the first low values of the standard deviation, it's this one, right?
Yes.
And for the second, so the second level of the moderator, so that's the mean of the unemotional traits, is this one. It's this line where it intersects. And the third high level of unemotional traits, 1 standard deviation above, it's this line, right? Are you seeing this?
Yes.
Yeah.
So we have 1, we have 2, and we have 3. Yeah? Okay.
This image is beautiful.
Look at this image. Really soak it in for a second, right? Are you seeing it?
Yes.
So
I've seen the light.
very good. I'm so proud of you. So when we talk about different levels of the moderator, it can be made very, very complex and hard to understand. But essentially, when you're doing these moderation analysis and you have a moderator and a predictor, you can visualize this relation quite easily in such a way where you see, well, if we're talking about what are our expectations of the relation between the moderator and the mediator in terms of hypothesis, then, well, it visualizing it like this, it absolutely shows. It clearly shows that there's a negative relation when you are low on unemotional traits. It's a stress relief. You have less aggressive behavior, as where you have when someone is very high on unemotional traits, there's a positive relation. So you can really clearly see these relations here coming back in such a plot. So, trying to visualize. Very good. Almost done. The final step. So, we have the coming back to the explained and unexplained variance part. If you look at such a plane like this, where do we find our error? So if I ask you to point to the error in this graph, what would you say? What is the error? Which distance? The distance between what and what?
Is it the green plane and the red data points?
Exactly. Very good again. It's just like what we did with all previous tests, where we plotted what the model expects. Our green plane is what the model expects, and the difference between one data point and the green plane at that point is how far you are off. So if all these red dots were much closer to the green plane, we would have more. What would we have more?
Explained variance.
Exactly. And in terms of showing this in what we've done in all our previous lectures, is we've said, well, can we just make it a bit easier to plot this data to see what is going on? So we could, even with such a complex model where we have a moderator and a predictor variable, and we have an interaction added, we could always go back to saying, well, if we have our participants on our x-axis and our outcome variables on our y-axis, what are all the data points for each individual? We could still say, what is the average for the entire group? And we could see what is the difference between the actual score for each individual with the total group average. And that is the amount of variance that there is, the total amount of variance. And if we apply such an interaction model, such a moderation analysis, you will just get one expected value for each and every person at the green plane that we've seen earlier. So we could state that even here, for each individual, we just can determine what the expected value is for this individual based on this model that we've just used now. So we have the explained variance part, which is the green line to the green circle, starting from the mean to that point. That's the explained part. And we have the unexplained part, starting from the green circle to the red circle, the difference between what we expect the outcome to be and the actual outcome itself. And that is, as very correctly stated earlier, the difference between the green plane and the actual red dot, the scores that we've found. So that means that even for such complex models, we can just bring it back to the amount of explained variance using the green vertical lines, squaring those, adding those up. We have the sums of squares of the model, and we can compare that to the means sums of squares of the model to the unexplained part. So you can go back, if you have this information, to getting a signal to noise ratio. What is explained, what is not explained. Or we could say, well, if we have this much that there is to be explained, and which part of that do we explain, we could have a proportion. How much do we explain of the amount that is to be explained? What is this proportion in percentages, for example? So if we express this as percentage, what is this then in terms of regression models?
R squared?
Exactly, that's your R squared. So I think we're there. Don't you think?
Yes.
Yes. This is it. This is the end. The end of the statistics for this course. Well, I'm getting a bit emotional. No. So this is it. Well, I really like to hear a bit of your thoughts on this online lecturing style, because well, it was a bit of a risk to do this, because well, we've seen some system crashes, but well, in the end, I think overall it worked out. So maybe you could share some thoughts on how you liked this style of teaching.
I think you did a really good job with helping the students to engage in the lectures itself, like asking questions, etc. And that just really helps with understanding the material that's being taught. So I think you did a really great job.
Thank you.
Agreed.
Yes.
I agree, and the setup was really great. Like you could see everything clearly, and the going from SPSS to the slides and back, and that was really great. And you were like really enthusiastic, which made it also like really fun for us, even though sometimes it was hard and boring and whatever. But it was fun to like listen to you.
Cool. It's still statistics, right?
It is still statistics, so at a certain level, it's not.
Yeah.
I just wanted to say that I think the energy that you brought to these lectures was really tangible, and that is something that you can really draw a comparison amongst other tutors. It must be extremely difficult talking to the screen, but you made me feel like actually you were talking to me. So that's a massive talent. Well done.
Cool. Thanks. This really good feedback. Thanks. Okay. I'll be sticking around for some questions if there are any, and I think we'll do still a Q&A next week. Roland will initiate that, and he will post it on Canvas. So I'll be seeing you again, but for me this is the final lecture. Thank you for listening, and I really enjoyed teaching you. Bye, everyone.
Thank you, Sharon.
Thank you.
Bye.
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 Thank you.
Thank you.
Thank you.
Thank you.